Can you hear me?
Yeah, I can hear you. Please
Okay,
go
yeah,
ahead.
sorry.
Okay. Uh, our device name is Luft right? Luft means air in Germany. We named it so because our device enabled to characterize light in the air.
Our device is shaped of a pen. With our device, we can input characters to computer by lighting them in the air. We used MEMS accelerometer and a neural network for characteristic recognition.
For our device, we set two purposes. First is replacing existing device like keyboard or touch panel. There are the people who are unfamiliar with using keyboard, for example, elderly people and children. There's people who and there is people who can't use keyboard but can write by pen. Second is as a new way to input. Using keyboard when you're in VR or AR world using head-mounted display is difficult and spoils the immersive feelings. Input by pen is always more natural action, and our device enables to communicate without voice and touch. It's important point to avoid infectious disease.
Then I'll show you how our device works. The gesture to light 0, inputted 0, and 2, 3, 4, and 2 again, and 3. Pre-check our device works without special software. It works as one of keyboard on Windows and other OS.
Our device is mainly constructed with STM32 microcomputer, 3-axis accelerometer, and button. For our first prototype, we used STM32 development board. For our second prototype, we designed a PCB circuit board and we used surface-mounted components. So it became smaller and lighter and more natural shape as pen. We plan to add battery and Bluetooth module for wireless, but we can't finish it by this presentation.
When button was started to be pushed, our device started recognize value of accelerometer. When button was released, our device entered recognize. Blue line is x-axis, yellow is y-axis, gray is z-axis. Then it started to normalize data for next characteristic recognition step. Originally, data is recognized 20 times per second in each three axes. If button was pushed for, sorry, originally data is recognized 20 times per second in each three axes. If button was pushed for 2 seconds, it gets 40 values. If button was pushed for 2.5 seconds, it gets 50 values. Normalization program converts them to 6-dimensional vector.
Our idea is there's the same features when putting the same character. Experiment profits. These are graphs of value and of accelerometer during writing a character. Left one is graph during writing character A. Right upper is another time A. Right lower is for B. You can find same two sharp edges of gray line and blue line in red circle. And also can find same edges of only blue line in red small circles. Graph of B doesn't have those two features. But how do we teach many and complex features for all characters?
We decided to use neural network. We need some breakthrough to transplant it on microcomputer for its limited resources. For fast prototype, we made learning data for 5 characters, 0, 1, 2, 3, and 4. We load them 100 times each.
We made a neural network like this. It has two hidden layers by all connected 32 nodes and wave function as an activation function. We made learning part of neural network by Python. After learning, We dumped parameters and we transplanted it to C++ on microcomputer.
These things I call breakthrough. We had to make software execute neural network on C++ by ourselves because there was no good library to transplant it to microcomputer. And we had to manage lack of RAM and ROM to transplant neural network on microcomputer.
And our device uses HID class to input as keyboard, so it doesn't need any special device driver on PC.
This is the result. Our device has some problems mainly because of lack of learning samples, but characteristic recognition almost succeeded. This time we used only 5 characters, but our device will have enough remaining strings to recognize parameter for all alphabet and some symbols. As conclusion, our device needs more samples to use practical use. And smartphone also has accelerometer. We think making a new way to input using similar software that will be effective for infection disease countermeasures. Thank you for listening.
Thank you for this very interesting project. So writing in the air is very nice, and I very appreciate that you use the German word for air, Luft, for your project title. Are there any questions from the jury? Luke.
First, unmute my. So very nice project. So to make your pen to write in the air. Now you have used the MPU 6050 module together with your STM32 microcontroller. Now this MPU 6050, so this accelerometer, it has accelerometer, but this also has a gyroscope, a 3D gyroscope. Now, yeah, if you want to know the position of how things are being done, if you want to derive position from acceleration, you have to integrate the acceleration 2 times. And each time you accelerate, you have to add a constant, so that things that you do not know. So with the gyroscope, you're calculating the changes in speed, of rotation speed. So you have to integrate that once. So I very much wonder, so why have you only used the accelerations? So why did you not use, for example, the gyroscope? Or even better, why did you not use the gyroscope and the accelerometer, as you already have it from your sensor?
We did the same experiment to gyrometer and magnetic sensors and all of 3 sensors, but the best sensor to pick up features of characters was when we used only accelerometer.
So have you also been considering using a Kalman filter, for example, to determine the shape or the space that you're traveling through?
Are you?
So these sensors are not measuring very accurately, so especially to know how you're moving. So if you're using a Kalman filter, you can derive that. So the problem is if you use an accelerometer only, so probably maybe if I would write a tree and you would write a tree and somebody else would write a tree, maybe that's is not the same, and maybe I could expect that your algorithm could have difficulties with that.
Well,
have you tried it for many people writing
yes.
these for? Okay.
We have to make a learning data from many people. Yes, this time only two members. Is that okay?
Yes, very good, very good.
Thank you.
Interesting project.
Can you share with us how you may apply to solve some problems in the real world?
Our device enables to input character without touch to a touch panel or speak voice. So our device will effective to infection disease contaminators and well. And there are some people who can't use a keyboard or mouse. So our device will be a new solution to that people.
Okay, thank you very much. I think we have to move on time. So thank you for this very interesting presentation. Alice,
Thank you
please
very much.